Okay, hello everyone. Welcome to the webinar. Today we're going to be talking about the brand new KeyLines version 5 and how it can help you with your geospatial graph data. My name is Dan Williams. I'm the product manager for KeyLines. I look after the product direction for KeyLines and work with our customers to help understand their challenges and make KeyLines the best it can be. The plan for today is to, before I get going and talk about the new version of KeyLines, I know not everyone on the line is a KeyLines customer or familiar with what KeyLines can do. So I'm going to start by talking a little bit about visualizing connected data on maps, some of the challenges around geospatial connected data and how to turn that data into meaningful insight. So I'll set the scene and then we will take a look at what's new, show you the new features, show you how we can address some of those challenges. That should take around about 30-35 minutes, and then we will move into the Q&A session. So we do want this to be an interactive webinar. We'd love to have your questions. We appreciate not everyone can join live, and we are recording the session for those of you who can't join live, and we'll make that available as soon as it's ready. But for those of you who have joined live, you get the opportunity to ask me questions, so please do. Anything you can think of, throw your tricky questions at me. You can send them using the Q&A panel, which is available in this go-to meeting, and we will answer those questions at the end of the session. That's about it for introductions, so we'll jump right in and talk a bit about connected data on maps. And before we do that, I guess I should explain what I mean by connected data visualization altogether. I know most people on this webinar are probably familiar with this, but just in case there's anyone who isn't, by connected data, we're really talking about data which is comprised of entities, which we call nodes, and connections between those entities, which are often called edges, and we call links and key lines. And on the screen is what I guess you could describe as a big bag of nodes and links. There's no kind of structure to it. It's not particularly attractive. And this is one of the first big challenges, and one of the first big things that you need to think about when you're trying to visualize connected data is how to arrange it on the screen. If you throw all of that data on the screen as nodes and links, typically what you'll get is not a lot of insight altogether. So one of the first things that you need to think about, and we're going to come back to this when we start talking about maps, is how to arrange the data on the screen. So I want to start out by showing you just a few pictures of the art of the possible and how connected data can be brought to life through visualization. So we'll start out with this picture here. This is a picture of a layout. So a layout is what we call the algorithm that figures out where on the screen to put those nodes and those links. And as I've said there, a good layout puts nodes in the best possible place. And you can imagine that's quite a subjective thing. What does it mean to put nodes in the best possible place? And this picture is an example of a good layout. It's good because it tells you things. It tells you, for example, that these nodes up in the top are very closely connected. They all talk to each other. If these were people talking to each other, or machines which talk to each other, or financial transactions that were linked to each other, we can see that this is a very dense area of the network, whereas some other parts of this, like over here on the left, we can see a very different shape to the data. We can see one node that's kind of a hub for these other nodes, and without this hub node, these nodes would be completely isolated from the rest of the network. We can also see things like singletons, nodes that aren't connected to anything, or this little component, as we call it, of two connected nodes that aren't connected to the rest of the graph. So you can imagine, even by laying out the data in this way, we've already learned a huge amount about the connected nature of the data. And really what we do here at Cambridge Intelligence, I'll talk more about KeyLines later, is we give you the tools to help you get this kind of insight from connected information. Connected data could be anything from insurance data to Internet of Things to cybersecurity to intelligence and law enforcement. Lots and lots of applications for this, and many of those applications have a geospatial nature, and that's what we're going to be talking about today. So that's a layout. The layout helps a huge amount. It's a very important part of things. A layout has to be something that can handle very large amounts of data. What you see on the screen here is a new layout that we released a few months back called the organic layout, which is handling a very large number of nodes and arranging them in a sensible way. You can see the higher level you are, the more you zoom out from your data, the more kinds of structure emerge. We're going to look at this data later in the webinar and talk about how we can put it on a map. But to give you the background here, this data is all about insurance claims. Each one of these little kind of creatures that you see arranged around here is a typical insurance claim. You have people own policies. Policies might involve a claim, which might involve a vehicle. It might involve third parties and witnesses, and it might involve damages to the vehicle, which might be fixed by a garage. So each typical insurance claim will have a little kind of universe of these different entities that are connected together. And in general, those are isolated things, but occasionally you get big structures emerging. This thing here implies that there's a lot of insurance claims that have something in common with each other, maybe a particular person or a particular a garage that's being used to fix the claims. So we can see interesting structures emerge at a very, very high level, and a good layout enables you to do this kind of thing and understand your data at a very high level, as well as being able to zoom in and see the detail. So visualizing connected data is something that you can't do at all without a good layout. Just to talk about a couple more bits of jargon and the bits of background capability that we're going to be talking about today. The next part of it is all about styling. So everything I showed so far was just a bit gray and boring. Ideally, you want to bring your data to life and put a bit of color and interest into it. And it's more than just making it look good. It's also about conveying information. Here you can see the same data that I showed in the first screen. There's that tightly connected cluster at the top, and there's that hub node over on the left. But now we can see, just by glancing at this, that these nodes actually represent people. We've chosen to use an icon to show that they're people. We put their names underneath the node so that we can identify them and tell them apart. And we've also used size and color to mean something. In this case, we are sizing nodes by their importance in the network. In this case, we're sizing them by their betweenness score, which means how crucial are these people to the shortest paths within the network. If you took them out of the network, what effect would that have on the paths between people? And the big characters here are important in that respect. If you took them out of the network, it would have a big effect on the network. In fact, this guy over here, if you took him out of the network, he would render all of these people completely isolated, for example. So he is much more important than some of these nodes up in the top who are talking to a lot of people, but if you remove them, then the world would carry on without much change. So using color and size to get across information is another really important part of connected data visualization. And again, we need to think about how we're going to apply that to maps and geospatial data when we come on to looking at that problem. And everything I've shown you so far has been static. They've been static pictures. They've been and when a picture is static, it's reasonably useful, but things get a lot more useful when you can interact with them. And by interaction, I could mean very simple things, such as being able to click on things and drag them around, maybe open them up and explore around the network. Say, okay, now find me this person's connections, or now let me zoom in on this person and see who they're connected to. This kind of interaction makes what's potentially a very tangled web of information suddenly manageable, because people can explore it in their own time, they can play with it, and they can help get their head around it by manipulating it and interacting with it. So interactions are a really, really important part of this kind of data visualization. And it's very important to be able to open up those possibilities when you're trying to get information across in this way. So interactions can be very simple things like dragging and moving things around, or they can be much more complicated. This is an example of something called the combos feature in KeyLines, where not only can we move nodes around, we can also open them up and realize that an individual node might in fact be summarizing a much more complicated network below it. Here you can see us drilling down into an IT network, finding individual nodes and seeing how those underlying nodes are connected to the rest of the network, but only opening them up when we need to get insight. Again, it's all about making it easy for people to find what they need without overwhelming them with a huge amount of clutter. And it's very hard to do that. It's very hard to make the perfect diagram or infographic for this kind of data that it's just a static image. It's much easier to do it if you can allow people to interact and explore with the data. Okay, so I think that's enough background. I just wanted to set the scene with some of the challenges of visualizing connected data before we start talking about maps. Everything you've seen, those images were generated with KeyLines. Those of you who don't know KeyLines, it's an SDK, it's a JavaScript toolkit which allows you to embed visualizations like the ones you've just seen into your web applications. So you can download KeyLines, you can install it in your web application architecture, and you can control it and get those connected data visualizations in your own products or your own analysis platform. And it's designed to work in pretty much any modern browser, any platform, touch devices, desktops, machines, any web browser, any platform, and give you fast, interactive connected data visualizations. So all of this is great, and we can get fantastic insights as I've just shown you, but then somebody comes along and says, well, that's great, but I really want to put that data on a map. And this is where a whole new set of challenges emerge. And we've been addressing these challenges for several years now. We've had our first version of map mode in KeyLines for a number of years, but we've just released a brand new version that overhauls that and addresses some of the trickier challenges. So I'm going to talk you through some of those challenges. Here's a picture which really shows the challenge pretty well. I call this picture the Boston hairball. And one of the great things about the Boston hairball is you can't even tell it's Boston because the whole of Boston is hidden completely behind the hairball, which makes it very difficult to even know where in the world you're looking at, even though there's a map. So this is one of the first problems you get with connected data, is that we've lost that layout. You remember I said the layout was putting nodes in the best possible position on the screen. Well, if you're forced to put nodes where they belong on a map, then they're no longer in the best possible position to convey insight. They have to be where they are, and we can't do anything about it. So now we're back to that bag of nodes and links that I showed you at the very beginning, and we have a bit of a challenge already. Now, there are solutions to this which involve getting rid of the map. One of the most famous solutions to this was when people started drawing schematic diagrams like this map of the London Underground. It's a fantastic solution. It's basically a layout. It's exactly what a layout is. It's arranging the nodes in the best possible place to solve a problem. In this case, the problem is how to navigate your way underneath a big city. And the nodes are in a wonderful place to help you do that. But it's kind of cheating because we've basically got rid of the map. We are playing completely free with the positions of nodes. We've thrown away the map. And the map is really a bit of a kind of a virtual idea. We'll come back to solving this kind of problem and replacing maps with more generic images later on in the webinar. But first of all, I want to talk about the more typical scenario where you can't just throw away the map and you do have to show your connected data on a real picture of somewhere in the world. So we need to address these problems. One is layouts. We don't have the freedom of layouts anymore. So how can we convey insight without that ability to run a layout? Related to that is the interactions. I was showing you examples of dragging nodes around and interacting with things. And again, we can't just drag nodes around anymore. If this node represents MIT, I can't just drag MIT and put it up here in the north of the state because that's not where MIT is. So we don't have the ability to interact. We don't have the ability to lay things out as much on a map, and that's a challenge. There's another more subtle challenge which you may not have thought of, which is that we are restricting the amount of data we can show now. Imagine each of these nodes represents some kind of station, and maybe our data set has credit cards that were used at that station, and it has people linked to those credit cards. So you have an interesting network of people, credit cards, and stations. But when I put that information on a map, the only nodes I can show are the nodes which have a geospatial location, which are the stations. And I've lost that information about people and credit cards now. I can't see it because people don't have a location that I can put on the map. So missing data is another big thing that we need to think about how we can address. And there are many others. I haven't talked about them here, but there are other practical challenges too, like how you can label your nodes when there's a lot of other distracting clutter on the map, like the labels of the place names as well. So there's a lot of challenges you come across when you're putting data on maps. And I want to talk about some of those challenges today. And I'm going to do that by introducing KeyLines version 5. The latest version of KeyLines, it was released just a couple of weeks ago. And It's a major version, version 5.0. Major versions are where you tend to upgrade the engine behind your software, and we've updated our map engine very considerably since the first release of it. We've also updated some other aspects of KeyLines. We've updated our image loading engine as well, which is giving you a great responsive, fast performance when loading lots of images into your charts as well. But we're not going to talk about all of the features of KeyLines 5 today. We're going to focus on the main thing, which is the map engine. And one of the side benefits of the new map engine, which is the ability to put scalable images behind your charts as well. Think of that London Underground map, and I'll show you some more examples of that later in the webinar. So let's start with maps. The KeyLines map mode has been overhauled, and the first thing I want to show you is just give you a general overview of using the map mode in KeyLines and talk about interactions, because although I said that we're hampered now with maps with interactions, we can't drag things around because they have a certain position. I can't move Las Vegas from where it is. But one of the exciting things about maps is it opens up a whole new set of other interactions that you didn't have before, because there are now two pieces to your visualization. There's the graph visualization itself with all of its interactions, but there's also the geospatial system, which comes with a whole bunch of interactions of its own. If you just look at the picture here, you can see, for example, the whole state of Nevada. I've colored it orange, and I'm highlighting airports in Nevada, and I can do that because I've got extra information about state boundaries, for example, which I can use to good effect. So I'm going to skip to a live demo here. This is KeyLines version 5. Those of you who are familiar with KeyLines and its map mode before will notice things in here like the improvement we've made to the overall performance and smoothness of the map mode. It's very smooth to drag and pan. It probably won't come across particularly well in the webinar, but on my screen it's very smooth indeed, and it will be on your end user screens too. We've improved a lot of the things under the hood of the way KeyLines interacts with the leaflet mapping engine, which is what we base our mapping on. In particular, we're using the most recent versions of leaflet, which open up opportunities for you to use a whole range of plugins, third-party plugins for the mapping engine. And I'm going to show you a few examples of that today. A really simple one is the geofencing I talked about before. As I move my mouse over these states, you can see the state boundaries being highlighted. That's not a KeyLines thing, that's a leaflet thing. But if I were to pick a state like Nevada, we can see that now something interesting has happened, because what we've done is first of all, we've used the mapping services to say which nodes are within the boundaries of the state of Nevada. Then we've taken those nodes and we've asked KeyLines, the graphing visualization engine, to find me all the nearest neighbors of the airports in Nevada and make everything else in the map fade out. So I can see now that this data, by the way, is the 50 busiest airports in the US and the connections between them. So I've got access to the two busiest Nevada airports, Las Vegas and Reno, and I can also see where those airports fly to. So I can see San Diego and Phoenix being highlighted as well. And you can see the KeyLine styling is allowing me to highlight the airports in the state. And now I've got insight and clarity. Even though I can't do layouts, even though I can't drag things around, I'm still able to explore potentially large amount of data just by having those intuitive interactions. It's very intuitive to see things highlight as you move over them, and to be able to click on them and to filter and fade out things that aren't important. We don't have the power of layouts, but we do have the power of interactions, and this makes it a lot easier to navigate your way around. So this is just a simple example to show you KeyLines running in map mode, and we can see how you can imagine how interactions can be very, very important in this kind of situation. So that's the first tip, is make the most of interactions. The next thing I wanted to talk about is this whole problem of missing nodes. How do we deal with information that doesn't have a geospatial coordinate? Lots of different ways you can do this, but the one I wanted to focus on today is all about data modeling. So in this picture, this is one of those insurance claims I mentioned earlier. So I've zoomed right in on that that pretty big layout I showed you earlier on. I'm looking at one person. This person has an address, a phone number, and an insurance policy. And on that policy, they made a claim, and the claim involved other people. It involved vehicles, it involved garages, and so on. And just a tip, slight aside, but one thing we often get asked is how to remove clutter on a graph. And one thing we often recommend is not showing, only showing labels on your links if they're necessary. Here's quite a good example of that. So in general, we're not showing labels on a link. It's kind of clear that a person linked to a policy means that person owns a policy. But where there is ambiguity, we show the labels. So here you can see this person is connected to the claim because they were a witness, whereas this person was just involved in the accident, for example. That's a little aside, but it's quite a common question we get as to can we remove labels from links, or when do we need to show labels on links? So it's quite a nice example of showing them where they're useful. But what I really wanted to talk about here is the problem of geospatial data. And in this particular data set, only 2 nodes here have geospatial information. One of them is this home address of the person on the right, and the other one is a garage where we have been able to look up their address and get a location for where it's based. So if we were to put this on a map, we would no longer have geospatial connected data. We would have geospatial data, but we would just have 2 isolated nodes because there is no link between these 2 nodes. And all of the interesting connections will be lost because there's no geographic data. So one thing you can do in this situation is modify your visual model. We did a whole webinar on this topic a little while back, which we definitely urge you to take a look at. But in this case, what we're going to do is basically say, let's make a link between people if that person, let's do 2 things. Let's first of all make a link between the person and a garage if a person made a claim where the damages were fixed by that garage. And the second thing we'll do is we'll transfer the address properties, the geolocation of the person's home address, and put it on the node as a property of that node. So that means we now reduce the data model to just 2 nodes with links between them, and both of those nodes have a geospatial piece of geospatial information. That's really powerful. This is what it looks like on a slightly larger collection of those insurance animals we talked about. When I run this animation, you can see, there we go, the KeyLines has remodeled the data. And now we see things like this. So a typical insurance claim would look like this, a person linked to a garage. And a more unusual insurance claim might look like this, where you have maybe a garage, maybe not that unusual, you have a garage that's fixed several people's insurance claims. Or in this case, slightly more unusual, you have somebody who goes to different garages to have their insurance claims fixed. Again, maybe not that suspicious. One of them may be a body shop and the other one may be specialized in engines, but that is something we can now see by remodeling the data, and it would have been very hard to tell that from the original data set. So remodeling the data is fantastic for a lot of reasons, not just geospatial insight, but in this case, we've now reduced the data down to a set where every single node has geospatial coordinates. And that means we can now put it on a map and see connections. So this is what happens when I put that data set on a map. And now we can see some patterns we couldn't see before. So we can see that typically, remember, people are purple and the garages are green. We can see that typically people tend to travel to nearby garages to get things fixed. These people are traveling to their nearest garage. These people are traveling to their nearest garage, and that all makes a lot of sense. But these lines that I highlighted in red, KeyLines lets you highlight links in any color you want. These lines are people who have traveled an unusually long way to go to a garage, and that may be interesting because if that's not an insurance company's recommended garage, they may be interested in why people are traveling so far to it and whether there's any kind of insurance fraud going on with inflated claims from a particular garage, for example. So this is a very practical way to get more insight out of your connected data if you want to see it on a map. I would definitely encourage you to watch the webinar on visual modeling for large data sets. You can get to it from the Cambridge Intelligence webpage, looking at our webinars section. And it's not the only way to solve the problem of missing data. There are other tricks too. I'll show you one more in the next section. So finally, I wanted to talk about the map tiles themselves and choosing the best map to use for your data. There is certainly more than one way of doing this, and I've got two good examples which illustrate it here on the screen. The one on the left is using base map tiles from Esri. It's using a satellite view of part of a city, and we've got superimposed on that is an overlay showing the names of streets. Very useful in this case. It's a law enforcement use case. We're trying to understand a crime and how a crime unfolded, and it's pretty useful to be able to see the streets, to see the satellite imagery, and to understand exactly where things happened. And information, a lot of information is very important here. On the right-hand side, we've got a very different kind of map. This is a dashboard showing the health of an IT network. And in this case, we really don't want the detail of the map. We're not really interested in the names of these countries or any spurious information. We just want to glance at it and immediately spot the important thing. In this case, the important thing is some kind of problem about how our factory in New York is connecting to the outside world. That is a very different kind of use case and needs a very different map. In this case, this is an SVG image that I got from Wikimedia Commons. And it's perfectly suitable for my use case. So I want to show you a little bit about how KeyLines can cope with different kinds of mapping. By the way, the image on the right also shows you another answer to that nodes with missing coordinates problem. In this case, we are manually choosing coordinates for the public internet and a central server because they don't really have a geospatial location. In this case, it's purely aesthetic reasons. We want to show these things on the dashboard at a high level. They don't have a physical location, so we choose an aesthetically pleasing place for them to create a nice dashboard. With a dashboard, you have a lot of control over aesthetics. With a real crime scene, aesthetics are not important at all. What's important is accurately portraying the information you need to show. So let's skip over to KeyLines again and take a little look at what's going on behind the scenes. So this demonstration is available on our SDK site. Shows how you can integrate with Esri. Esri is a very popular provider of maps and mapping services. What we're doing here is integrating KeyLines with Esri. All of the KeyLines demos come with source code that you can view examples to see how they're done. This one shows you how we use the Esri leaflet plugin to access Esri services and maps. It shows you how you can change the base map. So as I click these base maps here, I can turn on and off different mapping views. It also shows you how you can work with overlays. So I can turn on those street overlays to show adding additional layers into the map. And it also shows you how you can integrate geospatial services with KeyLines. So this show police stations button is a simple example. When I click that button, two things are happening. One thing is that we're calling out to a geocoding service and saying, within this map view, where are the police stations, and getting back those police stations as geospatial geocoded items. The second thing that's happening is we're adding those items directly to KeyLines in the chart so that I can interact with them using KeyLines, and I can detect click events on them, and I can make them part of my KeyLines data model so that I can see how they play with the other data in my particular case or crime scene. KeyLines version 5 is fully integratable with the Esri leaflet plugin, which gives you access to all of the Esri services available via Esri leaflet. It's also has a lot of new options which we've exposed to allow you to do things such as change the coordinate reference systems on your maps to give you maximum flexibility as to what maps you use. The second thing I wanted to show you was the dashboard and dig into this in a little more detail. What's interesting here is that this is not really a map. And again, think back to the London Underground map I showed you before. That wasn't really a map, but it's serving a similar purpose to a map. It's giving you context to the positions of nodes. And one thing we can do here is if I double click on one of these nodes on my dashboard, such as the New York node, what's happening here is we're now replacing that map image with a new image, in this case a floor plan. This is definitely not a map. It's not even spatially accurate because I've got the ground floor and the first floor arranged side by side. It's really all about giving context. And now I can see by zooming in that the real problem, that alert that I referred to earlier, is between this particular machine. Maybe this machine is calling out to the internet and it's never done that before, and we think there might be some kind of unusual activity which is worth monitoring and understanding. So we get both the high level view on the map, and then we can drill down and see the details by double clicking on a node. And these maps, as I say, they can be purely virtual. If I click on the central server, I might show some kind of virtual zoning or some kind of network infrastructure to help me understand what these nodes mean, which might not be geographic at all, but it makes use of the same technology. It means I can zoom and pan and interact with this as if it were a map, which is very powerful indeed for bringing a little bit of context to otherwise very dry network infrastructure diagrams. So this feature again is new in KeyLines version 5, and again we provide demos which show you how to use it and how to create these visualizations in your code. Again, this demo shows you all of the key functions that we used in order to achieve this, and you can view the source code and get the same effect in your own applications. Okay, so let's go back to the presentation. Just to summarize, really, a lot of what I'm talking about today is not specific to the new version of KeyLines. It's general advice on how to get the most out of geospatial connected data. Don't let the requirement to put connected graphs on a map ruin your visualization. There's a lot of ways you can really get extra insight out of it. Think about interactions. Think about what extra interactions your map and your mapping service gives you and make the most of them. Think about your data model. Consider whether you can change your data model to convey geospatial insight better, particularly if you can show connections between nodes on maps by manipulating the underlying data model in the way I showed. And think really carefully about the right map. It could be as simple as finding a map that doesn't have labels that distract and get in the way of your nodes. It could be about integrating with a third-party provider. Either way, make sure you choose the right map for your situation. And take a look at KeyLines version 5. It's been thoroughly revised and optimized for connected data, geospatial visualizations, and hopefully you've had a glimpse of some of the great new features over the course of the webinar. For those of you who are already KeyLines customers, we have the usual set of resources for you, so you'll be able to go to the site, go to the download section, get the latest version that's available now, with all the instructions about what you need to know to upgrade from previous versions. There will be a developer update coming out soon. Look out for that, which will have a little video that will talk you through the upgrade process to version 5. And if you're not a KeyLines customer but you'd like to try it out, please get in touch with us and we can look into arranging a trial for you. That's all I wanted to say, I think, on KeyLines. So we'll now move to the question and answer session. So just as a reminder, please do send in your questions. There's a Q&A function on the webinar, and we'd love to see your questions there. I think there's a couple of questions coming in now, but now is the time to ask if you have any. So one person asked a little earlier on, what is the upgrade path from version 4 to version 5? So as I said, you can go to the download site, the download page of the SDK site, and it will talk you through that. And there will be a webinar, a video, I'm sorry, coming out shortly, which we'll send to all developers that will talk you through the things you need to know. Another question we have is, can we use our own tile server? Yes, there's basically KeyLines is using Leaflet, and Leaflet allows you to get map tiles from any server. So often you'll be pointing at a server somewhere on the web. So all the examples I showed you today were pointing at either freely available open source map providers, or in the case of Esri, using the Esri Leaflet tool, connecting to that with an Esri developer license. So you'll have to obviously make sure you're licensed to use whatever servers you're using for your product. You can also Another common requirement is to use an offline tile server. So in some cases, you may not be able to connect to the internet at all in your application, if they're a secure application, for example. So you can use an offline server too. We do provide some instructions on how to connect to a tile server. And as long as you have the infrastructure to set up an offline tile server, you can absolutely connect to it. Another question is, there's a question about, are there any tips on dealing with cluttered maps? So any more tips on dealing with cluttered maps. So I guess I showed you a couple of examples of handling clutter with interactions and with the kind of high-level dashboard approach, drilling down when you needed it. I can show a couple of other ideas for that, for dealing with clutter on maps. One of the most powerful things where you have a lot of clutter on a map is around filtering. It's very tempting or it's very common that people will give their users filters to filter things down. So here's an example of quite a lot of clutter on a map. Again, it's US airports, and we're using a filter to filter things down. One thing I would definitely think about is whether you want to pre-filter your data. So in this example, there's a lot of clutter which is overwhelming at first. One really good tip might be just to put in some filters early on. So for example, I can find a filter that makes a bit of sense here. Here I'm just showing United Airlines, and I'm just showing routes which have more than 7,000 flights a year, I guess. So starting off in that mode so things are less overwhelming, and allowing users to add data in is often a better way than turning all your filters off and having users deal with large amounts of data first and having the users clean up the mess. So another top tip would be filter things out and let the users bring it in, rather than put the responsibility on the users to clean up the clutter first. We have a question about whether Mapbox vector data can be used instead of raster tiles. So there's two parts to that, I think. Using vector data and using Mapbox. So the engine behind KeyLines version 5 is still Leaflet. We haven't changed the underlying engine. That's simply because Leaflet has a huge variety of third-party plugins, and it's very popular with our customers. And we would rather have a very tight integration with Leaflet that lets us exploit what it can do than have something thinner that will work with multiple different engines. So unfortunately, we don't support Mapbox. We only support Leaflet. That said, any of the Leaflet plugins are available, and I believe it's possible to access vector tiles through Leaflet. I'm not sure it's something we've tested directly. We don't have a demonstration to show it, but you're very welcome to try that out and get in touch with us on support if you're having any troubles with it. So scalable vector tiles is certainly something that we should be able to look at using. Mapbox, on the other hand, is not the map provider we're using here. Someone's asking, have you tried the performance of layouts with at least 2,000 nodes? I don't know if that's specifically a map question, but obviously on the map, we're not doing layouts. So I guess that question is not a specific map one. But yes, we do test our layouts on much larger than 2,000 nodes. We have a performance harness here. So if I generate 2,000 nodes, which was what you were asking, and run a typical force-directed layout on that data set. So this particular layout, which is our organic layout, is running in about 3 seconds. That's one of our faster layouts. And we do test performance up to much higher numbers as well. So the layout is a very computationally intensive part of the operation. So you're definitely right to ask about layout performance, but we think it's pretty competitive, and particularly this organic layout is something like 6 times faster than our previous standard layout. So we're pretty pleased with that. Someone says, are there any transition options when switching between different background contexts as you have had shown? So I guess that's the transition between the different maps. Yeah, it's probably worth digging into the source code of that demo to see exactly what we're doing here. Basically, KeyLines has a transition between the network mode and the map mode, which fades out the map and removes it. So we can do things like fading out the tiles and replacing them. In this particular example, we're changing the map and then we're moving the locations of things. So we're doing something fairly simple, but you could pretty easily code in other things. So you could have everything fade out, I guess, and then the new map appear and then the nodes fade in. Or you could try something more interesting. I guess that's one maybe we need to follow up on afterwards to find out what kind of thing you'd like to do. But in general, the KeyLines API is pretty flexible. You can chain animations one after the other. So if you wanted to have a fade out, move, fade in, or you wanted to have a sharp transition, or you wanted to remove animation altogether, then we could certainly do those things. So maybe that's one to follow up on afterwards to talk about exactly what you want to do. There's a question about planning a responsive geomap where it fits perfectly into the parent element. Which it sounds like the question may have a particular challenge in mind there, so it may be something we need to follow up with on support. In general, we do have some plans in the roadmap to do some more native resizing of keylines to fit within the parent element. I think at the moment the way keylines works is we have a function which allows you to adjust keylines to cope with changes in the size of the parent element, but you have to do a little bit of the work yourself. So we do have some plans in the future to take away some of that heavy lifting for you. I can't give you a release date for that at the moment, but it is something we would like to do. So it could be the answer is a straightforward yes, hopefully in the future, but do get in touch with us on support if there's a more specific problem there that we can help with. And if it's something specific around maps, definitely happy to have our support team take a look at it. I'm looking at the Q&A. I don't think there are any more questions, which is nice because we're about 2 minutes to go before the end of the 45 minutes we had planned, so that's great. Thank you very much to everyone for joining us. Hope you found it useful. As I said, look out for the email with the recording. If you're a KeyLines customer, look out for the developer update video as well, which shows you about how to upgrade to version 5. And if you have any questions, remember you can get in touch with us. My email address is there on the screen. Support at keylines.com is the familiar support address if you're a customer. Otherwise, contact us on the email addresses you can see there, and we'll be happy to answer your questions.